All right, everyone, welcome to Chapter 7. Chapter 7 is talking a lot about trigonometry and right triangles. And we are going to start today with section 7.1, which is just the introduction to all trigonometric functions. Okay, so first of all, what exactly is trigonometry? It is a branch of math, just like algebra or geometry is, but it is concerned with angle relationships in triangles. There are 6 trig functions. Let's start by listing all 6 functions and their abbreviations. So the first one, well, it's not really the first one, there's no order, but one of them is called sine. Okay, so it's read S-I-N-E, and we say sine. Its abbreviation is just the first 3 letters, S-I-N. But we do not read that as sin, we read that as sine. Okay? The second one is spelled C-O-S-I-N-E, and that's read cosine. Its abbreviation is also just its first 3 letters. But again, we don't read that as cos, we read that as cosine. Next one is called tangent. Okay, now we learned about a tangent last chapter in circles. Okay, this is not the same tangent. Okay, some words in the English dictionary have multiple meanings. This is one of them. Okay, this is not a tangent line to a circle that touches a circle exactly one point. Okay, this means something different that we'll learn later on today. Its abbreviation is also its first 3 letters, T-A-N. Okay, those are the 3 basic ones, and those are the 3 that we'll use most of the time. However, there are 3 other ones as well. So the next one we're going to spell C-O-S-E-C-A-N-T, and that's read cosecant. Okay, this is actually the only one whose abbreviation is not the first 3 letters. Its abbreviation is C-S-C. The next one is S-E-C-A-N-T, and that's just read as secant, and that's abbreviation is its first 3 letters, S-E-C. And the final one is called the cotangent, whose abbreviation is also its first 3 letters, C-O-T. All right, now if you have a scientific calculator out in front of you, you'll see that 3 of these words appear on the calculator. Sine, cosine, and tangent should be on all scientific calculators, usually right above the numbers. Okay, we are not going to really need them today, but we will for the rest of this chapter. Let's continue by looking at the 3 most commonly used functions, the sine, the cosine, and the tangent. We'll use the picture in the diagram to set up the trig ratios. All right, the first one is the sine. The sine of an angle is the ratio, as soon as you see ratio, you're thinking fraction, of the length of the leg opposite the angle to the length of the hypotenuse. Okay, so what does that mean? Let's take a look at this triangle here. Okay, we can only take the sine of angles. And in fact, when we're looking at triangles here, we can only take the sine of non-right angles. We can only take the sine of acute angles. Okay, so let's look at, for example, angle A. Okay, we would write this, the sine of A, and what does that equal? That equals the ratio of the length of the leg opposite to the angle to the length of the hypotenuse. So the ratio, that's a fraction, of the leg that is opposite the angle, so we call that the opposite leg, to the hypotenuse. So let's look at our picture here. What leg is opposite angle A? So here's angle A. The leg that's opposite that would be little a. And what's the hypotenuse? Well, the hypotenuse is across from the right angle, so that's little c. So our answer here would be little a over little c. And we can do the same thing for angle B. So we can say the sine of angle B is the leg opposite that, which is little b, divided by the hypotenuse, which is little c. We cannot take the sine of c at this point. The next one is the cosine. The cosine of the angle is the ratio, so again, fraction, of the length of the leg adjacent to the angle to the length of the hypotenuse. So we would write this. Let's look at A again. So we'd write cosine of A equals the ratio of the leg adjacent to the angle. So we say the adjacent leg to the hypotenuse. So look at angle A. What is the leg that is adjacent to A? That would be little b. What is the hypotenuse? Still little c. So our answer here would be b over c. And again, we could do the same thing for b. We could say the cosine of angle B is equal to the adjacent leg over the hypotenuse. So in this case, it would be a over c. Finally, the tangent. The tangent of an angle is the ratio of the length of the leg opposite to the angle to the length of the leg adjacent to the angle. So let's write that down. We would write tangent of A is the ratio of the leg opposite, so the opposite leg, divided by the leg adjacent, so the adjacent leg. So look at angle A in our picture. The leg opposite A is little a. The leg adjacent A is little b. So our answer here would be A over B. And finally, we can also do the tangent of B, which would be the opposite leg to B over the adjacent leg to B. So here's B, the leg opposite is B, the leg adjacent is A. So our answer here would be B over A. So how are we going to remember all that? Well, there's a fancy made-up word that people made up a long time ago to help us remember this. And that is read SOHCAHTOA. So the word is read SOHCAHTOA. Okay, and how does that help? Well, let's take a look. We would say that the sine of an angle is equal to the opposite leg divided by the hypotenuse. And that's where SO comes from. Sine equals opposite over hypotenuse. All right, then we would say the cosine of an angle is equal to the adjacent leg divided by the hypotenuse. So that's where CAH, ka, comes from. Cosine equals adjacent over hypotenuse. And then TOA, the tangent of an angle is equal to the opposite leg divided by the adjacent leg. And that's where TOA comes from. So, if we remember SOHCAHTOA, we remember the three trig ratios that we need. But you said there was 6 ratios. There is 6 ratios. The good news is, if we can find those 3, the second set of 3 are very simple. The other 3 functions are just the reciprocals of the first 3 functions. Given an angle x, here are some reciprocal identities that you have to know. So the first one says that the sine is equal to 1 over the cosecant. So sine and cosecant are reciprocals, which means cosecant is 1 over the sine. And remember, sine is opposite leg over hypotenuse. So cosecant is hypotenuse over opposite leg. Cosine and secant are reciprocals. So since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And tangent and cotangent are reciprocals. So since tangent is opposite leg over adjacent leg, cotangent must be adjacent leg over opposite leg. But really, all we got to do is find the sine, the cosine, or the tangent, and then we can flip them over to find our cosecant, secant, or cotangent. There are two other identities that apply to these functions as well. Let's take a look at the tangent function in further detail. So tangent, we said earlier, is opposite leg over adjacent leg. Well, if we divide both numerator and denominator by hypotenuse, we would get opposite leg over hypotenuse divided by adjacent leg over hypotenuse. Opposite over hypotenuse is just the sine. Adjacent leg over hypotenuse is just the cosine. So we can actually say that the tangent is equal to the sine over the cosine. And since cotangent is the reciprocal of that, the cotangent would equal the cosine over the sine. All right, lots of things going on here. Let's take a look at our first example. So here we have a new symbol. There's a new symbol up here. This is called, it's a Greek letter, and it's called theta. It kind of looks like an O with a little line across the top. Some people write it with a little squiggly at the end, like that. All you need to know is that it's a variable, okay? It doesn't mean anything different than x. Basically, it's just a variable that we use a lot for angles, okay? So the question says, find the value of the 6 trig functions in the triangle below. Well, the nice thing is our triangle is completely filled out for us. We have all 3 sides ready to go. So you can start with any of the 6 functions you want. It does not matter. Okay, I usually like to start with sine. So let's say the sine of theta. So look at theta and ask yourself what leg is opposite that and what's the hypotenuse. So the sine of theta we would say is 4 over 5. And that's it. Your sine of theta is 4/5. Maybe next we can do the cosine of theta. Remember, cosine is adjacent leg over hypotenuse. So look at theta. What leg is next to theta? That would be 3. And what's the hypotenuse? It would be 5. So our cosine of theta is 3/5. All right, next we can look at the tangent of theta. So I showed you 2 ways to do this. We can do sine divided by cosine, or we can just look at the triangle and say, all right, here's theta. What's the opposite leg over adjacent leg? Opposite leg is 4. Adjacent leg is 3, so our tangent is 4 over 3. The good news is, once you've gotten those 3, like I said, the other 3 are very simple, okay? Remember that the reciprocal of sine is cosecant. So if the sine is 4/5, the cosecant is 5/4. The reciprocal of cosine is secant. So if the cosine is 3/5, the secant is 5 over 3. And the reciprocal of tangent is cotangent. So if the tangent is 4/3, the cotangent is 3/4. So there you have your 6 trig functions of theta. Okay, here's another one. And once again, we're just going to walk through finding those 6 functions in any order. It doesn't really matter what order we do them in. I'm going to do them in a little different order this time. I'm still going to do the sine first. So the sine of theta, opposite leg over hypotenuse. Opposite leg over hypotenuse is 8 over 17. But right away now, since I know that this reciprocal of sine is cosecant, I'm going to do the cosecant next, and the cosecant is just 17 over 8. Now let's look at the cosine. Cosine is adjacent leg over hypotenuse, so 15 over 17. And I know the reciprocal of cosine is secant, so 17 over 15. And then we have our tangent. Tangent, remember, is opposite leg over adjacent leg, so 8 over 15. And the reciprocal of tangent is cotangent, so 15 over 8. And there we have our 6 functions. All right, what if they don't give us a triangle? That's okay. They give us enough information right here to draw one. So let's start by drawing a right triangle. And you can put theta in either one of the two acute angles. I'm going to put it down here. And the directions say that the sine of it is 12 over 13. So opposite leg and hypotenuse are 12 and 13. So that right there tells me the sine of theta is 12 over 13. Now we can do Pythagorean theorem to get that third part. So I'm just going to call this A. Okay, so we can do a squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. A squared equals 25. So A equals plus or minus 5, but this is the length of a triangle, so it has to be positive. So this third side here must be 5. And now I have my full triangle. Now I can find the other 5 trig functions. We don't have to find the sine because it was already given to us. And in fact, without even doing the triangle, we could have found one of the functions. We could have found the cosecant, because remember, cosecant is just the reciprocal of sine. So our cosecant is just 13 over 12. But now for the other 4, we're going to need to look at the triangle. All right, so let's start with the cosine. The cosine of theta is adjacent leg over hypotenuse. So that would be 5 over 13. And the reciprocal of cosine is secant, so that would be 13 over 5. The tangent of theta is opposite over hypotenuse, so 12 over 5. Sorry, opposite over adjacent, so 12 over 5. And the reciprocal of tangent is cotangent, so 5 over 12. And there we have the other 5 functions besides the one that was given to us. All right, same thing for example 4 here. They give us enough information to draw this triangle out. But I'm going to do something a little different here. Since I already know the cosine, I'm going to do the secant right away. The secant is the reciprocal of that, so it's 41 over 40. And we're done with one of the 5 without even drawing the triangle. Now I'm going to draw my triangle out. I have a right angle here. Again, it doesn't matter where you put theta. You can put it in either of the 2 angles left. I'm going to put it down here again, just to stay consistent. The cosine is 40 over 41. So the adjacent leg is 40 and the hypotenuse is 41. Okay, doing Pythagorean theorem, let's call this side B, or anything you want, doesn't really matter. So 40 squared plus B squared equals 41 squared. And solving that, we should get B is 9. So now we can answer the other 4 remaining trig functions. So the sine of theta, opposite leg over hypotenuse, is 9 over 41, which means the cosecant is 41 over 9. And then the tangent of theta, opposite leg over our adjacent leg, is 9 over 40, which means the cotangent is 40 over 9. All right, number 5 says, given the secant is 25 over 7, find the value of the other 5 trig functions. All right, so again, I'm going to go ahead and solve for one of them right away. I know the secant is 25 over 7, so I know the cosine must be 7 over 25, because cosine and secant are reciprocals. Okay, now I can draw my triangle out. And Again, it doesn't matter where you put theta at. I'm going to put it down there again. The cosine is adjacent leg over hypotenuse. So 7 over 25. Through Pythagorean theorem, again, you would get this third side is 24. I'm not going to go through that again, but there's the third side of 24. And now we can answer our other 4 questions. Sine of theta equals opposite over hypotenuse. Cosecant is the reciprocal of that. Tangent of theta equals opposite leg over adjacent. And cotangent is the reciprocal of tangent. And here's your other 5 trig functions. Which brings us to our last one here. The tangent is 6 over 7. I'm going to go ahead and write down what I know. I know the cotangent must be 7 over 6. Okay, now I can draw my triangle. Tangent is opposite leg over adjacent leg. Okay, so doing Pythagorean theorem, we don't know the hypotenuse this time, so I'll call it C. So 7 squared plus 6 squared equals C squared. 49 plus 36 equals C squared. 85 equals C squared. Now we don't get a whole number this time, it's fine. Take the square root, you get C equals root 85. Just write down root 85. Do not write that as a decimal. Root 85 is what we want. And now we can answer our other 4 remaining questions in any order. So I'll start with a sine. Sine is opposite leg over hypotenuse, which means that the cosecant is the reciprocal. We already have tangent and cotangent, so we need cosine, which is adjacent leg over hypotenuse, and secant, which is the reciprocal of that. And there we have it. Okay, that is the end of section 7.1. That is your introduction to trigonometric functions. Next time we will look at solving for missing pieces of right triangles using right triangle trigonometry.